Okay, so here up on the board we have your special topics questions, and that dealt with um, talking about the brain in general. And to perhaps refresh your memory, that dealt with what was it? The Navy did a study. It was about a woman that did her cliff diving, and then it was the memory aspect of the musician Clyde, and I think the final portion of that was where neurologists did studies of criminals, or in this case, he called them psychopaths, for instance. So that is what the special topic is about, just the brain only, and that's what we're talking about here, okay? And then those are the last two questions that we dealt with from the brain video. These, however, are ones that would have pertained to, what was that? The brain, who's in control, and the other one was the brain about decision making. Okay? So, with this, back to when that rat study was done, what was the significance of what that neurologist did? Okay? So, we took a rat. And what did he do with a probe? Maybe you can remember. Okay, so he damaged part of the brain. Now, this was after doing a control. Okay, so what might have been a control in that study? Okay, and it was probably the same rat. Okay, a normal one where, okay, here's this maze, the reward is the cheese. Okay, navigate your way through this maze, grab your reward. Okay, then take that same animal, take a probe, and damage his brain. Okay, so what was the significance of that study after that brain was damaged? So even where the damage was done, that did not affect that rat's cognitive skills of memory. Okay, so excuse me, I think it's fair to say that memories are not stored in one spot. I think that's what we had said at that time when we had discussed that earlier. Now, I just had that paper. It's right here. Okay. So memories are not stored in any single place. I think that's what we could take from that. So memories are not stored in any one place. We could say memories are stored at random. Okay? Okay? So that's what we mean by they're not stored in one place. They're randomly stored throughout your cortex. Okay? So what brain structure might be in conflict with the amygdala? In other words, the amygdala sounds the panic portion of your brain. But if you were to logically think with your consciousness, okay, what might be in conflict with this? What is our decision maker? What part of the brain? It's part of the cortex, but yeah, your prefrontal cortex would be in conflict with that. That's correct. Okay. This next question, this is probably pretty self-explanatory. What about olfactions? Well, you've got that pen in your mouth when you're mumbling, and then what did you say? So what does that mean to you? That's true. But what does the olfactory nerve deal with? It's a special sense, like sight and hearing. It's not a general sense like pain, touch, and temperature. Not speech. Smell. There we go. Yep. What do olfactions deal with in the brain? The sense of smell. Okay? Now, this, okay, this is you could say is a trick question, because it is. It is a trick question, okay? Because as we decipher sight, even just as vague as you can, where do you think that sight is deciphered? Somewhere in the cortex, but where? So what do we mean by back when you say that? Okay, from biology, what bone would that be? The occipital cortex. Okay, the reason that we're saying this is a trick question is because that that occipital cortex portion of the brain, what is that communicating with another part of the brain? Where does your coordination come from? The cerebellum. So then, one of the things we had said, it would make sense that your occipital cortex and your cerebellum would be right next to one another, because that is where sight is interpreted. So we don't take anything away from this. Occipital cortex. And the reason we say that and how we know that they work together is you people can walk down the hall just fine. You can navigate turns just fine, okay? The moment that we put you out there on that football field, what was taken away from you? Your sight. So what does that tell you about your coordination when this does not have the opportunity to do what it should? It's not sending input to where for your coordination? Your cerebellum. If it's not getting anything for that, that's why it's difficult to walk in a straight line. And I can't imagine how difficult it would be to navigate in the dark, okay? Has anyone ever had to do that at home? I'm sure we have. You can't see, you start bumping into things. It's not that you're uncoordinated, but it's just not getting any information from your occipital cortex because you can't see. It's dark. Okay. So then we know your second cranial nerve is what? Your optic nerve, which means that is dealing with which special sense? It's going to be that of sight. So then, well, what happens if your brain has to decode something that you can't see? When you look, you're 3 steps ahead of me, okay? When you look at something in general, you get an entire picture, but your brain cannot make a full picture of that because of the sight in your eyes that's focusing on your cornea. Why not? Say that again. Yeah, you can't see, and then yes, you've got blind spots. So no matter what you're looking at, as far as this purple mug. Oh boy. Are those all the same brand? Okay. So you're just the odd one out here? Okay. Oh, of course. I look up by the straw. It doesn't have this, what do you call that?
It's like a straw holder. Yeah.
Okay, so your straw holder is different than the other three, okay? So when you look at these, you can't see the whole thing, but that's not how your brain works. What did you say earlier? So your brain takes all these pixels and makes its best guess. That's how sight is decoded, okay? So the brain makes its best guess. And one of the things that's significant about that is when you are born, you have special senses that overlap with one another. And that was the infant Robert, okay? So think of it this way. In the video, I think it shows like there's a, let's see, there's like a pan, a pot or a pan on the side of a table. What happens is that inadvertently gets bumped, the pan falls to the floor, okay? So it's something that Robert certainly hears, but what does that do to his sight? It's shaking like this. Why is it doing that? It hasn't fully functioned yet, and those two senses are overlapping. And the visual patterns that form are certainly not what we see today, okay? Because the brain has just not developed enough to make those visual acuity perceptions, if you want to call it that. Okay. This is tricky because of the abbreviations, okay? Because I would think that probably 7 out of every 10 people, if you asked, what does the PNS stand for? Okay, so in this case, this is the parasympathetic nervous system. That's true. So you're 3 of the other 10. But if you, in general, you ask what does PNS stand for, they're not going to say parasympathetic nervous system. They're probably going to say what instead? Your peripheral nervous system, okay? So in your parasympathetic nervous system of the autonomic nervous system, what happens when there's a glitch in your rest and repair division? It was something like this. Sleepwalking. That's right. Okay. So some of these questions, they obviously overlap then. What is your brain's best decision maker? Your prefrontal cortex. That's right. Okay. So you're going to have a 50-50 chance with this. We know there's 4 parts of the brain. Okay? You have a cortex, you have a brainstem, you have a cerebellum, and then what's that 4th part? Starts with a D, that's right. The diencephalinon. So that is the central part of the brain, but the reason we said you got a 50-50 chance, the thalamus gland is the central part of your brain. Just because of the anatomy of how the brain sits in the cranial cavity, how would you know it's not the hypothalamus? Because is that above or below? That's actually below the thalamus gland, okay? So in this case, if someone, it's not Lou Gehrig's disease, it's not an ALS disorder, it's not anything like that, but severing this corpus callosum, that is the central part of your brain, okay, that is actually below, okay, it's actually below the thalamus. When we say, what is the corpus callosum, it's below that, but that allows one part of the brain, you might have a memory stored in your right cortex that then can shift over to your left cortex. Well, how's that possible? That's exactly what that is. But that's called the corpus something. Is it the striatum or the callosum? It's actually the corpus callosum, because in that structure, okay, because as that's coming up, it looks something like that. The corpus striatum that is up top here. Okay, the corpus callosum is a little further down in that of the brainstem. So yes, it is the corpus callosum. Oh. No wonder you have a strange look in your face. Okay, because what happens is if someone has these inadvertent twitches, okay, that means one side of the brain is affecting the other side. And when that happens, we call that epilepsy. Okay? If someone has epileptic seizures, that means one side is starting to twitch more than the other. You might think stroke or something to that effect, but no, that is not the case. It is a treatment for epilepsy when they have epileptic seizures. Okay, it's a treatment for epilepsy. Okay, the last thing I want to do, and then you have a little over 10 minutes, is the breakdown of this, okay? So multiple choice questions from chapters 10 and 11, okay? How many, and your cranial nerves. How many cranial nerves are there? There's 12, okay? Can we, if you can do the order, which we said you are responsible for that, don't worry about sensory, motor, or mixed, okay? We're not too concerned about that, okay? So think about brain structure and maybe, if it's a specific question about a cranial nerve, it's probably actually in its name. So what we mean by that, this would be a specific function of a cranial nerve that is actually in its name. We wouldn't expect you to know what's the specific function of the vagus nerve, okay? That would be a tough question because it has so many functions because it winds its way through your thoracic cavity. Because vagus is, I believe, Latin for wanderer, and that's why it's called your vagus nerve, because it wanders all the way through your cavity, okay? So another one would be which cranial nerve deals with sight? What does that? Your optic nerve, okay? So then maybe what type of nerve moves your eyes? So it has to be something with movement. That's what a motor nerve does, which is the only cranial nerve that has motor in its name. Oculomotor. That's right. Okay. And oh, they do. Okay. No, they would not know that. Okay. And your vocabulary, I know those have been passed back because I just had one student's left and I handed it back to him this morning. Okay. So I will look for those papers that you asked about earlier, this chapter here. That's, yeah, it could be all of them. Because if you knew them then, chances are you're going to know them now, okay? Because we want that to be in your long-term memory, okay? Because I'm willing to bet even yourself, Mr. Wagner, do you remember good memories from high school? Yeah, because it's in your long-term memory. It's every day in science class. That's in your long-term memory. We'll do that tomorrow. I'll have them up on the board. Tomorrow. That's what it says, yes. Yep. So that's why we have part 1 and part 2 up here. Okay. Special topics questions, that's these. Okay. Nervous system chart, that's the one where it had the breakdown of, it had like central nervous system in a box. Then on the right, it had said somatic nervous system, autonomic nervous system. You're just utilizing that as a roadmap, if you want to call it that. Okay? So, can I erase this? So, in short, what that means is we're talking about this first hour. Okay? So, on that chart, okay, it had central nervous system over here, and then it had your somatic nervous system, then over here was your autonomic nervous system. Okay? Well, how does this work? This is mainly controlling what? Right. So what that means is if you have a visceral receptor, okay, which would be that in your eyes, for instance, okay. For basketball, that's what we use the example of basketball. Okay, so if you had to jump up to catch a pass, how do you know you need to jump? Because you see it coming at you. Oh my gosh, I got to jump to grab this. So in your eyes, you have these visceral receptors that sends a signal to this part of the brain through what we call the ascending tracts. And this is on that, you don't have to memorize all of this. This is all on that table. Okay? So then this sends an outgoing response. And we see this, there's a box down here. Okay? And in that box, is it controlling smooth muscle or skeletal muscle? Yeah, so this is controlling your skeletal muscle. So we'll just put SM for skeletal muscle. Because do you have conscious control over this? Yes. Yes, you do. Do you have conscious control over this? No, certainly not. So on this side of the brain, perhaps you received a signal in your visceral receptors, for instance, I didn't go this far in depth in the first time around, but let's say inside your liver, okay? That visceral receptor is going to speed up the breakdown of sugar. So in a stressful situation, to keep things really, really short here, in the DVC championship, was that where Mackenzie made a layup at the end of the game? That was the DVC championship? Or it was against St. Mary's, that's all I remember. But what might be going through your mind, you know time is expiring, you know you need to get the shot off, and you're probably telling yourself, don't miss. Okay? So that would be what we call probably a stressful situation. So what's going to happen is that stressful situation from these visceral receptors, your eyes and inside of your liver as well, is going to speed up that conversion of glycogen because there's two outgoing responses here. Okay? One of these is speeding up your heart rate, speeding up your respiratory rate. Do we remember what that was? What do we call that? It's a type of response. Flight or fight response. So flight or fight response. This was that wave that we were talking about. When your heart rate is going up and up and up, it's because of this outgoing response. Well, once it's all the way up to the top, it's got to come back down. And dopamine probably does that. Or no, not dopamine. Melatonin probably does that. Because why do people artificially take melatonin? To go to sleep. So if this is the flight or fight, this would be your rest and repair division. Okay? So this is affecting smooth muscle. And then this is affecting your heart rate and respiratory rate. So what you're doing is you're looking at something and saying, what is actually happening in the brain? So you're jumping up to grab that ball. Why is that happening? You have these visceral receptors in your eyes sending this up to the brain. The outgoing response is saying, oh my gosh, this ball is about 7 feet off the ground, so you need to jump up and grab it. That's what's happening on this side. This, you might be nervous because you know time is about to expire. So you might be panicking, and when that happens, what happens to your motor reflexes? It might go to garbage because your heart rate is pumping so fast and things like that. Okay. Don't beat yourselves up about this. You're all intelligent. That's why you're in here. Okay? So the bell's about to ring. Take a few moments to collect your thoughts, and we'll go forward. You have a paper. Make sure your names are on it, and I will collect it. Okay. Thank you. Thank you. Okay. Thank you. Oh, thank you. All right. So we will catch up to you next time.